All right, so I'm going to be working through the review sheet for the first test. Just make sure that anything I write down, that you're writing down, and that you're keeping good notes, because you can use this on your test, so you want to make sure you understand exactly how I'm getting the numbers I'm getting. So first, to fit comfortably, each person needs 3.5 square feet of space. They're already giving us the area. You have 14 feet by 14 feet square. How many people will fit inside the square? So to find the area of the square, you take the length times the width. So 14 times 14, which is just 196 feet squared, or square feet. So now that we have our total area and the area each person needs, we're going to divide these numbers. So 196 divided by 3.5. This gives us 56, meaning 56 people could fit inside of our 14 by 14 square. Following the same guidelines, how many people could fit in a semicircular stage? Well, we need to know how to find area of a circle. So to do that, it's pi r squared, but this is a semicircle, so we're going to divide it by 2 because it's only half. The diameter is 22 feet, so I need the radius, so the radius is half, which is 11. So using my formula, I'm going to take pi times 11 squared, and then I divide it by 2. So that means that the area of my semicircle is 190.066 feet squared. Okay? And then with this number, I'm following the same guidelines, so I'm going to divide it. So 190.066 divided by 3.5. Divided by 3.5. So we get 54. You can't have 0.3 people, so we're just going to say 54 people could fit inside of the semicircular stage. Following the same space guidelines, how many people could fit in an empty classroom that measures 36 feet by 40 feet? So again, I'm finding the area of my classroom by taking 36 times 40. And I get 1440 feet squared. And I'm going to divide this number by the 3.5 that each person needs. And I get 411.429. You can't have 0.429 people, so we're just going to say 411 people. Following the same space guidelines, how many people could fit in a 1 mile stretch? You have to remember that 1 mile is 5,280 feet on both sides of the street, okay? And the crowd is 13 feet deep. So here's my street. This is 13 feet, this is 13 feet, and this side is 5280. So I'm going to take 5280 times 13. That's for one side, and when I double it, this is how many square feet I have. So 13,780 feet squared. I'm going to divide it by my 3.5 that each person needs, and I get 39,222.857, but like we've already said, you can't have half a person. A softball measures 3 inches in diameter. How many softballs could fit in a box that measures 27 inches by 15 inches by 18 inches? To find the volume of a rectangular prism, it's length times width times height. So I'm taking 27 times 15 times 18, and I get 7290 inches cubed. To find the volume of a softball or a sphere, it's 4/3 pi r cubed. I don't know what the radius is, but I know what the diameter is. So that means that my radius is 1.5 inches. So I'm going to take 4/3 pi, and then 1.5 to the third. To do the third power, you click the caret button, which is right here, and then 3. So my volume of each ball is 14.137 inches cubed. So to find out how many balls, assuming they're touching at their diameter, I'm going to divide those two values. 7290 divided by 14.137. And I get 515. You can't have 0.66 balls. I may put it down here, because technically you could have if you cut them, but my answer is going to be that whole number. How many of the boxes above could fit into a room that is 36 feet by 15 feet by 15 feet? Notice this is in feet, whereas before we were talking about in inches. So to keep our things the same, I'm just going to multiply them by 12. 36 times 12 is 432 times 15 times 12 is 180 times 180. 432 times 180 times 180. So my entire room is 13996,800 inches cubed. And they want to know how many boxes. Well, the volume of my boxes is right here above. So I will divide this number divided by 7290. So I can fit 1,920 boxes in the room. Using the same softballs and boxes, how many softballs would fit in the classroom? So since I know there's 515 balls in each box, and I know there's 1,920 boxes, I'm just going to multiply those numbers. 515 times 1920. 515 times 1920. So I get 988,800 balls. 988,800 balls. So this is what we did that first week of class or so. Driver's license. How many different driver's licenses are available in Texas if each person's number contains 8 digits with no restrictions? We know we're talking numbers. So there's 10 options for the first spot, 10 options for the second spot, 10, 10, 10, 6, 7, 8. So really we're taking 10 to the 8th because there's no restrictions. That's how many different options there are. But what if there's no repeating options? That means this one could be anything 0 to 9, but this one couldn't be whatever digit that one was. This one couldn't be whatever digits those 2 were, whatever digits those 3, whatever digits those 4. So we're losing the options as we go on. So 10, 9, 8, 7, 6, 5, 4, 3. 1, 2, 3, 4, 5, 6, 7, 8. So for my 8 options, those are our 8 digits, those are my options. So I'm going to multiply those together, which if you remember factorials, this is technically 10 factorial minus 3 factorial, but I'm just going to keep it simple and multiply them out, so it's 1814400. So notice the difference. If there's no restrictions, you can have 100 million. If there are restrictions, it goes all the way down to 1,814,400. If Texas changed to a 9-digit system for new license, how many additional licenses would be created? Now they bolded additional, but really everything that we make with 9 digits is going to be new. So now we're just taking 10 to the 9th. So that would be your answer. How many license plates are available in Utah if the first 4 spaces must be letters? So there's 26 options, 26 options, 26 options, 26 options. And the last 4 spaces must be digits. So 10, 10, 10, 10. Because there's 26 letters and then there's 10 digits. And there's no restrictions. So 26 to the 4th times 10 to the 4th. On some license plates, If the letters or digits cannot repeat, how many different license plates are available now? So here, this can now be 26, 25, 24, 23. And then for numbers, I'm going to say that they're, now really, we talked about this, how O's and zeros look the same on a license plate. So I would say when you get down to numbers, you can't include an O because we can't repeat. But I'm not going to be that specific on your test. So I'm just going to keep it 10, 9, 8, 7. So 26 times 25 times 24 times 23 times 10 times 9 times 8 times 7. If they can't repeat, this is how many license plate options they are. 52000. If Utah adds one more alphanumeric character to all license plates, how many plates would then be available with no restrictions? So going back to the original, there's the 26, the 26, the 26, the 26, 4 alphabet letters, the 10, the 10, the 10, the 10 for the 4 digits, and they're adding an alphanumeric. That means a letter or a number. So now there's 36 options for that last digit. So I'm going to take 26 to the 4th times 10 to the 4th times 36. And it's 1.6451136 times 10 to the 11th. So I'm just going to go ahead and move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's how many answers there are. Right, the aspect ratio of an Android tablet is 5 to 3. If the display diagonal measures 8.5 inches, what are the height and the width? So this is your Pythagorean theorem. So they're telling us the diagonal is 8.5, and the aspect ratio is 5, and I'm going to say x to 3x. So we use our formula, our Pythagorean theorem. So we're going to take 5x squared plus 3x squared equals 8.5 squared. So this gives me 25x squared plus 9x squared equals 8.5 squared, 72.25. You can combine those like terms, so you get 34x squared equals 72.25. You divide by that coefficient, so x squared equals 2.125, and then you square root. We're only going to take the positive, even though technically when you square root you get a positive and a negative, because you can't have a negative height or width. So we need the square root of 2.125, 1.458. Now, that's not my answer. That is our x value. To go back up here and find the height and the width, you have to plug it back in for these sides. So we take 5 times the 1.458, and we get 7.29 inches by, then we're going to take the 3 times the 1.458, and we get 4.374 inches. What is the viewing area of the tablet? To find area, we take the length times the width. So using the values we found above, 7.29 times 4.374, we get 31.886 inches squared. Please make sure you give me your units. Using the dimensions from number 13, if you're looking at a picture full screen in portrait, you rotate the tablet to landscape. So we know that this side was 4.374, this side was 7.29, and now I'm rotating it. So my height is now 4.374. So to find this missing area, 7.29 over 4.374 equals 4.374 over some unknown value. We cross multiply 4.374 times 4.374 divided by 7.29. So the other side length is 2.624. So the dimensions are 4.374 by 2.624. Please complete the table below. So now this is the tires, which is what we did in class, and what we did when we went to the parking lot to get their values. That first number represents the width in millimeters. So for this one it'd be 235, for this one it'd be 245. The aspect ratio is that next number as a decimal, so as a percent, so 65%, 55%. The height, you're going to take this 235 times this is a decimal, which is 0.65, and divide it by 25.4, because there are 25.4 millimeters in 1 inch. So I take 235 times 0.65 divided by 25.4. So my height is 6.014. So for this one, now I'm taking the 245 times 0.55 divided by 25.4. 245 times 0.55 divided by 25.4. And I get 5.305 inches. So now to find the diameter, you've got to consider that a tire has the height on both sides. So we're going to double this number and add it to the 17. So I take 6.014 times 2 plus the 17. And I get 29.028 inches. So for this one, now both sides of our tire, right here and right here, are that 5.305 with the 17 in the middle. So I'm going to double the 5.305 and add it to the 17. And I get 27.61 inches. To find the circumference, we take pi times the diameter. Okay, so we're going to take that 27.61 and multiply it by pi. So this circumference is 86.739 inches, whereas this circumference, we've got 29.028 pi is 91.194 inches. Okay, after one real rotation, how many inches further has the bigger tire traveled? So this is our larger tire, and we're just finding the difference between them, minus that 86.739. So 91.194 minus 86.739. So it has gone 4.455 inches further. After one real rotation, how many times further has the larger one gone? So now you're going to take and set it and divide them. So the larger one divided by the smaller one, 91.194 divided by 86.739, and it has gone 1.051 times further. That's your K value, okay? With the bigger tire, the odometer is no longer accurate. When my Sorento turned 30,000 miles, how many miles have I actually driven? So to find that, you're going to take this 1.051 times that 30,000. 1.051 times the 30,000. So you've actually driven 31,530 miles. With the bigger tires, the speedometer is also no longer accurate. When I'm driving to Dallas, the speed limit's 70. When my speedometer reads 70, how fast am I actually driving? So I'm going to take that 70 times the 1.051, and I'm actually going 73.57 miles per hour. So look over the notes, quizzes, and reviews. You can use all of it on your test, and if you have any questions, I will be here early in the morning.